Hello, and thanks for joining us today. My name is Xavier Rose. I'm a mechanical engineer. I currently work over at NAVAIR in Lakehurst, New Jersey, where I'm a supervisor for one of our platforms. And with me today, I have the pleasure of talking with Dr. Miller. Dr. Miller, would you like to introduce yourself?
Yes, hi, my name is Dr. Arielle Miller, and I work for the Office of Naval Research, working as the NavalX Technical Director. And we're out of Arlington, Virginia.
Okay, awesome, awesome. I looked at your background a little bit. I saw you have a good, flow from the Navy over to, postgraduate work, and then, from private industry to government as well. Could
Mhm.
you just kind of go into a little bit of how you made the decision on going into the Navy and then transitioning over? We'd just like to hear a little bit about your background.
Yeah, so I was accepted into the Naval Reserve Officer Training Corps at Northwestern University for my undergrad. And so I got commissioned as a surface warfare officer with a nuclear subspecialty coming out of Northwestern uh, with a degree in physics. And from there, I joined the Navy as a SWO, got my pin, went to Navy Nuclear Power School and prototype, and then on to a nuclear powered aircraft carrier, the USS Enterprise, and served out my tour of duty. Upon completing that, so I was in for 5 years. Upon completing that, I had the option, right, to choose what to do, and I chose to get out and go into industry. Rather than go, back to grad school, even though I wanted to pursue a PhD. So instead, I decided to work and pursue my PhD, starting with my master's. So I went to go work for GE Nuclear, GE Hitachi Nuclear Energy. It was really important that I stay in nuclear. I kind of fell in love with nuclear when I was in the Navy. And so I decided to pursue my master's in nuclear engineering as well from North Carolina State. And from there, I just continued the majority of my career within the nuclear industry, starting with the commercial side and then transitioning into the government when I joined the Defense Nuclear Facility Safety Board. And over the course of those years, I got my professional engineering license in nuclear energy engineering, and also um, completed my PhD at Howard University in mechanical engineering, becoming the third woman to do so. And upon completing that, I had a wonderful detail at the Naval Research Laboratory that in part led to me coming to ONR to be the NavalX Technical Director, and here I am.
Awesome, awesome. That's a really impressive journey you've had. Dr. Miller, I know you've had a lot of experience with nuclear energy. You mentioned nuclear power school, and then follow-on study with that. Could you uh, go into any detail, any background on nuclear energy?
Yeah, so nuclear engineering is a very broad field. Like a lot of the other engineering fields out there, there's a lot of different places where you can kind of um, go. I've touched on a lot of different ones within the what's called the nuclear fuel cycle. So if we talk about what nuclear energy is harnessing the power of the atom. There's a lot of energy inside of an atom. There's a lot of energy that it takes to hold all of those protons and neutrons and electrons together. And so we're harnessing the power of the atom, specifically in the nucleus, and we're utilizing it to make heat that we then transfer into electrical energy. So we have just a really sophisticated boiler with a hot rock that makes steam. And that steam turns a turbine, and that turbine generates electricity. But there's a lot that goes into getting those uranium rocks, that uranium fuel into, because that's what we use right now, into a reactor. And so you have to mine it. You have to then use chemical processes to get it into the correct compound that you need it to be in. And then you need to do something called enrichment, because you need to have certain types of uranium, what are called isotopes. You need to have more isotopes of uranium-235 than you started with in the ground. So that's where you go into enrichment. And then you need to fabricate it into fuel. And that's another chemical process, because you're changing the compound again. And there is a lot that goes on in designing that reactor core, how much fuel you need at what enrichment levels, if you want to add other materials into the fuel, where that fuel goes, when you change it out. So there are nuclear engineers that primarily do reactor analysis. There's also engineers that just work on probabilistic risk assessment. So your question earlier about how long will a part last, when will it fail, that's something that probabilistic risk analysts do. In addition to determining how often we're going to have a failure, to determine what kind of safety systems you need. There are mechanical engineers that work on the mechanical components of a reactor in the power plant that do nothing with the nuclear side. There are material engineers, because you're exposing these materials to high radiation, to high heat for long periods of time. And then you have people that are handling what's called the back end of the fuel cycle, where now we need to manage that spent fuel. And what are we going to do with it? Are we going to store it? Are we going to reprocess it? Are we going to recycle it? And that can get you anywhere from nuclear criticality, which is where you're trying to make sure that you don't have too much nuclear material around, because it's not in a controlled environment. Your only controlled environment is a reactor. If you're going to be doing recycling or reprocessing, you're breaking down the fuel, you're changing the components again, the compounds, and you're trying to extract the stuff out that still can be used in a nuclear reactor, what's called fissile material, things that will fission when you point neutrons at it. And then, obviously there's also a weapons side to nuclear engineering. It's not something that I was involved in, but I think that the most interesting parts of nuclear engineering, the exciting parts, if you're interested about getting into it, is really in all these new reactors that are coming out, the designs that are really being fleshed out right now, or even designs that were started decades ago, but never really took off because there wasn't the need or the appetite for them in the industry. And so that you might hear about small modular reactors, or gas-cooled reactors, liquid metal reactors, thorium fuel, all of these different things, because they have new challenges to them, new radiation fluxes, new temperature levels, new fuels, and therefore new materials that are needed. And how do you, there is no data to tell you how long this stuff will last. We have decades of data on what are called light water reactors, which are the ones that we use right now, but we don't have a lot of data on any of these new reactors that are coming out. Small modular reactors are very exciting because they can be used in smaller areas and more remote areas where you don't need such a high base load of energy and electricity. There's also interest in reactors in space as we try to go farther and farther. And so the challenges around how do you get the reactor into space, and then how do you manage it? How do you operate a reactor in space? So there's new companies popping up all the time that are working on this problem. And that's really what I find really exciting, as well as we still have a challenge with nuclear waste in this country and how to manage it, how to utilize it. There's still a lot of energy in that waste. There's still a lot of actually good material in that waste. And so refining and improving upon processes for recycling and reprocessing the fuel is another key area that can help with the energy crisis and climate change, because, you know, it's a very green form of energy. And especially if we're reprocessing the fuel that we already have, that means we're not mining for more fuel. So all of those things I think are really exciting around nuclear.
You know, one thing I've noticed with your career path, you know, you've gone from the Navy to private industry to the government as well. You know, in various areas from physics to engineering. Is there one piece of advice that you would like to give to somebody who's looking at going into a STEM field, you know, considering a STEM field versus another major? Any one piece of advice that you would like to give them?
Oh, I have probably more than one piece of advice, but I would start with um, go for the job. Even if you think you're not completely qualified, go for the job, go for the opportunities when they present themselves. Be open to trying new things and taking up space in places that maybe you didn't think you were supposed to be taking up space, because I promise you, you're supposed to be there and you need to be there. And if things, you know, aren't, if it turns out to not work out for whatever reason, it's okay to go do something else, to go try something else, whether within the STEM field or, you know, to try things outside of the STEM field, because I think even that helps make you a more well-rounded engineer. So that would be my one piece of advice.
All right, Dr. Miller, thank you so much for your time today. You know, very insightful talk on nuclear energy, additive manufacturing. Your career field has spanned many areas. So thank you so much for your time today.
Thank you so much. Thank you so much for having me, for giving me this opportunity to talk about all of the different parts of STEM that I absolutely love. And I look forward to reading the essays that I get.
Thanks a lot.
Thank you.